Hello and good morning. We're starting chapter 4 today. So what is a statement? Okay, before we do that, or write a statement, before we do that, there's a test, sign up. So retest, sign up. Remember, if you've been playing in class, I'm going to let you test, but I'm probably not going to look at your test, okay? Retesting, if you read the syllabus, is only for students who are cooperating and working in class. So look here, write a statement. A statement would be like, New York City is in California. Well, even though we know that's not true, it's still a statement. A question, do you know what time it is? Okay, you can't use that in logic. It has to be true or false. A command, stop the dog. A statement allows you to say true or false. So if it's something that allows you to say true or false, that is a statement. Okay, let's talk about 4.1. Copy everything you see right here. Okay, so apportionment, let me give you the rest of it. Apportionment is dividing the whole, say, population into parts. Okay? The Hamilton plan, you take the whole population, divide it by how many people you're going to have represent the whole population. That's called your standard divisor. So what is the standard of divisor or the standard divisor? It's the number of people to each representative. The standard quota is the whole part of the quotient. And then you got the Jefferson plan, which uses a modified divisor. Turn to page 171. Okay, so I'm going to grab my book, and I'm looking at page 171. We're going to go over the Hamilton plan first, okay? So you take the total population. So if you look here on this chart, I'm going to make it a little smaller so we can see. If you take the total population of all of these made-up states, they say they want 25 representatives right here. So you're going to take the total, divide it by 25. So that's called your standard divisor. Once you do that, you're going to go ahead and take the population of each city, divide it by the standard divisor. And no matter what the decimal is, they round down. So in this case, there's 13 representatives for that city, 1 for this one, 4 for that one. This is called the standard quota. The whole number is called the standard quota, right here, the whole number. So the whole part, write that down so you know. Okay, so no matter what the decimal is, you do it that way. But if you see, there's only 22 representatives and it called for 25. So Hamilton said, look down here. Hamilton said, okay, we need 3 more. So he looked at the biggest decimal. So this one would get an extra one because 9 is bigger than 0. Here's another 9 right here. So this one would get 1. So that makes 2. We need 1 more. And the next biggest one is 0.6. So they would get 1. So those are the 3, and that's the Hamilton plan. Let's look at the Jefferson plan, okay? So the way the Jefferson plan works is you divide it, instead of by 800, okay, by the standard divisor, you would just experiment with that. You might go 700 and see how many representatives you get. And that's with the Jefferson plan. But if you look on the next page, 172, they experimented with 740 and they got lucky and they got 25. Okay, that's the Jefferson plan, where you experiment with the standard divisor. Okay? So what you're going to do today is 1 through 5 on page 83. And we're going to talk more about this section because there's a lot more to it, but we're going to do it tomorrow. Let's turn our attention now to college algebra. Okay, so look here. Retest signups are on the wall. And right here, you're going to complete the square. So you're going to move the 67 over. That's going to become a negative 67. You're going to divide by 2. And when you divide by 2, what happens is this cancels. So now you're going to get x squared minus 5 over 2x equals whatever that is. 33.5, I think, negative. Okay? Now you got to take half of this squared. So half of 5 over 2, and then you got to square it. So that gives you 5 over 4, and then you got to square it. So that's going to be adding 25 over 4 to both sides, or actually 25 over 16. 4 times 4. Okay? Once you do that, you have a perfect square here. So this is going to be x minus 5 over 4 squared equals whatever that is. Now, I say whatever that is. I don't know if 25 divided by 16 is a good decimal. Let's see if it stops. So 25 divided by 16 does not stop. So unfortunately, you got to go ahead and figure out the math here. Now, you might say, well, how do I do that? Well, you're going to multiply 33.5, put a 1 under it, and this is actually 33 and a half. So it's a little work here. So you're going to get 2 times 33, which gives you 66 plus 1. So that's 67 over 2, and then that's a negative, and then you're adding 25 over 16. So the least common denominator you have to multiply by 8. So 67 times 8 is going to give you 536. And then you're going to add the 25 to that negative, make that a negative. Okay, so I'm just going to say 536 minus 25. That's going to be 511 over 16. So that's going to be a negative 511 over 16. Okay? Right here. Now you're going to do the square root. When you do the square root, you're going to get plus or minus. So you're going to move this to the other side. So that's going to be a positive 5 over 4. And then it's going to be plus or minus the square root of this. Okay? Now the problem here is you have a negative, and according to our system, you can't take the square root of a negative number. And so you're going to put an I there. So you're going to put an I on the outside and leave it alone. On that one right there. Okay? And that's how I would handle it. They went a little bit further. Right here's the answer. We got the 511. We got the I. They put the I in front. That's okay. You could technically, when you're doing the square root, you could do the square root of that, which is 4. But that 4 would go on the bottom. So it would be 5 over 4 plus or minus. And they used I in front, the square root of 511 over 4. And that's what they have. Let's talk about today's work. All right, well, let's take a look at this one right here. So this one, you're going to multiply this times this. So you multiply the outside numbers. So 2 times 2 is going to give you 4. 3 times 3 is going to give you 9. So that's the square root of 9. The square root of 9 is 3, and 3 times 4 is 12. When you do this one, you're going to get a negative 6 square root of 6. When you do the inside here, that's going to be a plus 6 square root of 6. And when you do the outside, that's going to be a negative 9 square root of 4. The square root of 4 is 2, so that's going to be a negative 18 here. This cancels. So you're going to get 12 minus 18, which gives you a negative 6. And that's how you multiply radicals. You do the outside numbers. And if you don't see an outside number like the square root of 5, put a 1 here. Okay? So if you don't see it, put a 1. All right, today's work is right here. Make sure you distribute the negative sign and make sure you check answers. And we'll go into imaginary numbers more tomorrow. All right, have a good morning. Remember, the sign-up sheet for testing is up there.